Yesterday, you guys were doing that little discovery with the integer chips, where you were trying, or algebra tiles, where you were trying to model these multi-step equations where you had variables on both sides. And not sure how successful you felt with the tiles. I've had people tell me that the tiles didn't really make much sense or didn't really help or just, maybe confused you even more. Okay? It's fine. All right, some of you, I have heard people say that they kind of see the tiles when they do these. It's up to you. Everybody's going to find your own way. You're going to go with it. Today we're going to do it in a way where we're not using the tiles. We're going to do it in a more algebraic approach. Okay, so let's talk about these problems here. Start off with this example. Car rental has an agency has two plans. Plan A, it's $80 to rent the car and then $20 for every day that you have the car. Where Plan B, it's $120 to have the car and then $15 for every day that you have it. The very first question I always ask myself, and you should too, what is the variable? What do we not know in this scenario? Because we need to define the variable. Quinn? Yeah, so maybe we say D stands for the number of days. And you don't want to use two variables, you always want to use one variable. So give me an expression to write for Plan A. This is something we've been doing for a couple months now, just writing these expressions. We're just going to put it all together into an equation. Amelia? D? I'm just going to use D. 80 plus $20 for every day, that's Plan A. How about Plan B? Brady? $15D. Okay? So now the question is, when will these two plans cost the same amount? How would I write that as an equation? Hayden? Well, I'll stop you right there. Let's look at this equation, first of all. So he's saying that this is Plan A on the left. We want to know when that plan is equal to Plan B. So literally speaking, we're just going to put them equal to each other. And then we have a situation where we have a variable on both sides, which until yesterday we really hadn't seen that before. I think I gave you one last week just to try. So you guys yesterday were modeling these with the tiles and moving things around and subtracting and adding and different things. Well, how would you approach this more from an algebraic standpoint? Like, if I want, and I'm going to go step by step. It says to model this. We're not going to do that. But in these places here, I'm going to write down the steps that you're going to be doing. Okay? So step number 2, after you model it, what would you suggest? What do you think, Finn? All right, so he's saying subtract 80 from each side, Finn? Yeah. So from both sides. Here's what I'm going to do. Down below here, I'm going to I'm going to solve it while you're telling me what to write. So there's the equation. He's saying take away 80 from both sides. So now I'm left with 20D is equal to 40 plus 15D. Now be honest. How many of you would have said subtract 80 from both sides? How many of you would have said something different, step 1? Okay, you didn't have to subtract 80 from both sides first. So if you were thinking, I would have done something differently, that's okay. Because with these multi-step with variables on both sides, bless you, you can do them in different orders. Okay, so what would step, if we did 80 first, what's the next step going to be? What would you suggest? Ellie? Subtract 15D from both sides. Okay? So I'm going to follow her lead, come down here, minus 15D, minus 15D, and I am left with 5D equals 40. Jack? Divide both sides by 5. So for those of you that said, and if I did that, Jack, what do I get? D equals 8. Okay, so this would say 8 days. So if I did it the other way, and I know, Ellie, you had said you would have done it the 15D first, right? If you do that, if I took away 15D first, then my step would look like 80 plus 5D equals 120. And then I suppose you did minus 80 then, right? So then if we do that, look at where we end up. The exact same place we ended up doing it the other way. All right, so just to put your mind at ease, you don't have to follow a specific script with this. You can move the variables first, or you can move your constants first. It doesn't matter. But then you're just going to get yourself into a two-step or one-step equation. You just follow the rules that we've been doing up to this point. Now, the question follow-up here says, if a person is renting it for 4 days, which plan do you think would be the cheapest option here? So it's like, oh, I'm taking a long weekend. I'm going 4 days on this trip. Do I want to go A? Do I want to go B? Finn? For A, okay. How do you know that would work? Okay. Yeah, okay, I see what you're saying. Yeah. But 4 days would cost, it looks like $160 with plan A. And on this one, it looks like $180, right? So yeah, cheaper there. So does that mean if I went for 14 days, B is going to be the cheapest? Yeah, it would. Let me show you something here graphically. And no, you don't have to worry about graphing this yet, but we will eventually. If I were graphing this, and I was graphing like the number of days rented the car and the cost, plan A might look something like this. Like it starts off at $80 and it progresses up in a linear fashion. Okay. Plan B starts off a little bit higher. Actually, I'm going to do green. What's going to happen with plan B? Is it going to run parallel with A? Mikey?
It's going to be a small difference, but it's actually not going to be directly up. It's going to be a bit tilted down.
Will it ever touch that?
It will, but like only once.
Oh, it's just going to cross at one time, you mean?
Yeah.
Okay, yeah. So something like, terrible line, but yeah, you get the idea. I agree. All right, tell me something about this spot right there. What does it mean when those lines cross in terms of this scenario? What's it mean, Quinn? That's the days that they're equal, exactly. So right here, this would be down here at 8 days. And you see before that, if this is plan A, before 8 days, plan A is cheaper. After 8 days, plan B becomes cheaper. All right? Again, we'll spend a lot of time doing those as time goes on. All right, let's turn that over. Got a couple of problems here for you. And I know, yeah, I incorporated some fractions, some decimals, some good stuff here. So why don't you try the first 3 for me. Solving for the variables. And we're going to talk about them. Anybody get 2 for number 1? Be -2. -2? How many of you moved the 5x to the left? Like, how many canceled 5x out on the right side and moved it over? Okay. Did anybody move the 7x, like cancel 7x and move it over? Okay, that's fine. If none of you did it, you could do it that way. I think it presents more work though when you do it that way. So if you did it the other way, can you explain to us how it looks? What would you do? What does canceling 5x looks like? Go ahead, Jack. Mm-hmm. Okay. Good. Okay. Move the common terms to one side. He didn't have to move anything from the left to the right because the only thing over there was that one term, and then solve. Amelia? Because we don't want to break the 5 and the x apart yet. We want to still keep it together as a term. What we're trying to do is bring it over and combine it with this term first, then we'll divide. Because if I divide this by 5, Amelia, you're going to have to divide everything in the whole thing by 5, and then it gets pretty ugly. So get your like terms together first, and then you can divide. All right? How about on number 2? How many of you added 3 to both sides first? How many of you subtracted 1/4 x from both sides? Oh, that's popular. Okay. So after you subtracted 1/4 x, over here, tell me what this whole thing cleans up to look like after you combine and clean it all up. Quinn? Good. This becomes 2/4 x, which he reduced appropriately to 1/2 x, minus 3. These cancel, and you still have a positive 3 here. Now it's a 2-step equation from here. So what's the next step? Go ahead, Quinn. Yeah. Add 3. And you get 1/2 x equals 6. Might as well finish it out. Okay. X is, did you say 12? Mm-hmm. Did I write something wrong? What it?
No, because she was confused because it still was -3, but if you changed it, it would be
Like plus a negative? Okay. All right. All right, go down to number 3 here then. You have the freedom to move these things in any way you want. Like me personally, I probably would subtract 2.1x from both sides. Did anybody do that? Oh, a lot of you did? Okay. Well, then I'm not going to do it that way because I want to show you. Do it. You did it that way. Keep it that way. I'm going to show you a different approach. I'm going to say, you know what? The first thing I'm going to do is add 2. So I'm not going to do that step first. I'm going to add 2 to both sides. So that cancels this. So I'm left with 2.1x plus 5 equals 3.1x. So you guys probably did this step second, right? If you did it first, then it looks like mine. If you did it second, that's okay because I'm going to be doing your first step right now then. I'm going to move my x's together. So I'm going to remove my 2.1x over here and balance it. So I'm left with 5. This one works out nicely. Equals 1x. 5 equals x. There you go. Okay. Any questions on those 3? General question? Okay. No. 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 I knew what you were going to ask. No, like she's asking, is there a preferred way? Does one going to help you get? Not necessarily. The only thing I would say is just watch out. Like try to avoid. I know people that'll try to avoid. Like if I had, let's say, 8x minus 4 equals 3x plus 6. I don't know. I know people that don't want to move the 8x over here because it's going to give you a negative. Does that make sense? Like if I subtract 8x here, I go 8x, now it's like, oh man, I got a negative over here. But if I would have moved the 3x over there, it would have been a positive 5x. So no, there's really no better way, Amelia. It's just, the more you do, the more you'll get an idea. You'll look ahead. It's like you'll sense what's going to happen, so you'll make the moves before they actually happen. Let's try this last one together here, and then that'll be it. You write me an equation. This is like our car rental problem. Again? Yeah, go ahead. If you're right, solve it. Again? That doesn't look right, though. What should I like the equation. Oh, when you subtract 85x. This is 85x. You're not going to get that 2x, okay? That's good. Good. Got that. Okay, yeah, I'll go ahead and solve that then. Quick lap around shows me that most of us are getting this equation right. So you should have an equation that looks kind of like that. How many of you move the d's to the right side? How many of you subtracted like 85d and moved it over? All right, I'm going to do it the other way then. I'm going to subtract 100d. Just to show you. Okay, so it cancels here. I have negative 15d plus 75 equals 30. Now I'm going to get my 75 out of there. And I get negative 15d is equal to negative 45. Whereas most of you probably have 15d equals 45, right? Doesn't matter. Divide by negative 15.